Good morning, students. Today we'll discuss about large signal amplifier. In the large signal amplifier consists of Class A power amplifier, maximum efficiency Class A amplifier, transformer coupled amplifier, push-pull amplifier, complementary symmetry Class B amplifier. Class B power amplifier, base inverter, transistor power dissipation, thermal runaway. Introduction: when the loudspeakers is used as a load, then it is demands high power. This power frequent requirements of loudspeaker is unable to fulfill the using small signal voltage amplifier. Voltage amplifier are used as amplifying the low voltage signal as shown in the figure. Low voltage signal is given to voltage amplifier. It converted to high frequency signal. Then when high power is required to derive the load such as loudspeaker used as power amplifier are used for amplifier, improve the current capability signal, improve the strength of the signal. Here, what is the difference between small signal and large signal? Small signal we can take it as voltage amplifier, whereas large signal we can take it as power amplifier. Low power transmitter are used here, and high power transmitter are used here. Now coming to small signal amplifier, it is a small size. Coming to large signal is a very large size, and small signal is low cost as compared to large signal is very high cost. Voltage amplification is possible in small signal amplifier, whereas large signal amplifier power amplification is possible. No necessary heat sinks is available in small signal. Heat sinks are available to required for large signal. Harmonic distortion upside. Here large signal amplifier consists of harmonics, used as a free amplifier in television and radio receivers and TVs. Wherever the electronic company we can use it as a small signal amplifier, used as a last stage of public address system to derive the large speakers. And important feature of these amplifiers are: power amplifiers are bulky, harmonic distortion, impedance matching, power transistor are required, capable of handling large signal amplifier, efficiency of power amplifier. Coming to power amplifier are bulky for large amount of power handling which is obtained from power amplifier. High power transistor are required. Power transistor are large in size and heavy weight. Thus when heavy transistors are used in design power amplifier circuit becomes bulky. Harmonic distortion: when output signal of the amplifier is observed, then same time amplitude disturbances are present in it. These disturbances are called as harmonic distortion. Harmonic distortion causes when the output signal shows frequency component which are absent in the input signal. These frequency components are thus observed in the transistor characteristics. It consists of nonlinear. Coming to impedance matching, power amplifiers are used as last stage of public address system. Thus power obtained from the power amplifier is used as derived load speakers. For maximum power transfer from power amplifier towards the load, impedance matching necessary. Generally impedance of the loudspeaker is very low. When common collector configuration is used for built power amplifier is very low. When such as impedance matching, the best impedance matching we have to take CC amplifier. Now coming to power transistor, in the power amplifier the large signal we have to take considered. In power amplifier, the P equal to VI, power amplifier circuit should be capable of handling such power. The power heat sinks are used. Now efficiency of power amplifier we have to take. What is the efficiency? First of all, efficiency is nothing but output. It is the ratio of output by input. Here in the power relation, P naught output power by input power into 100. You want to input power means P naught plus P losses. Suppose efficiency is nothing but P naught output by output power plus power losses into 100. As shown in the above equation, the power losses are more efficiency decreases than happen which transistor operates active region. To increase the efficiency and to reduce the power losses, the Q point is located cutoff region here. The classification of based on biasing condition, based on amount of transistor bias, amplitude of input signal amplifier can be classified as Class A, Class B, Class AB, Class C. There are four categories classified into amplifier. One is Class A and second is Class B, Class AB, Class C. Here complete Class A means, how to define Class A means depending upon waveform. If it is waveform is completely half cycle and full cycle combination means it will take it as 360 degrees, that is complete cycle, the center of AC load line. Now coming to Class B, half cycle we need to take, that is 180 degrees phase shift and bottom of the load line in the cutoff region. Coming to class AB, more than 180 and less than 360, we can call it as class AB. Okay, if it is waveform is more than 180 and less the in the coming to negative part is the less than 360 is present. Coming to class C, less than 180. Okay, below 180, only half cycle, below half cycle is, it is called class C amplifier. Now let us we discuss one by one class A amplifier. Class A amplifier, its simple parts, it consists of one transistor and R1 and R2, RE, RC and CE, and VA is the input signal, C0 is the output capacitor, RL is the load resistor. Here R1 R2 purpose is provide R1 and R2 and RE providing biasing and stabilization. And across coupling capacitor we are CE taken, okay, and CO0 is the coupling capacitor. So let us take, I am giving input signal. In this power amplifier, the output current flows a complete cycle of the input signal. Thus, obtain the conduction of the transistor is full cycle of the input signal. The Q point is located center of the center. This is called Q point. Q point is nothing but we need to take center part only. Okay, we need to take center part. Here, the Q point is located center of the load line or in active configuration. The transistor is thus bias properties to achieve 360 degrees. Output current flows and locate the Q point in the center. Let us apply small bias signal transistor when the half signal of this signal is applied, then transistor starts conduction and remain, and it will end of the half cycle for 360 degrees. Large amount of collector current observed in the collector terminal. Similarly, large circuit is also observed. The CE configuration is used. IB output both IC, VCE. The transistor conduct continuously, which receive the efficiency. But when harmonic distortion observed, then we may say that distortion is 0 compared to the types. The merits of the class A amplifier is output with this distortion, output flows the 360 degrees exactly conduction current. Demerits means low efficiency. It is present in almost 25 to 50% only. This is the demerits of class A amplifier. Coming to class class B amplifier, the simple equation of the class A we can take IC equal to Im by root 2, that is I max minus I minimum by root 2. We can VC, we can take it Vm by root 2, V max minus V minimum by 2 root 2, and power output is P equal to Vc into Ic, and V max minus V minimum by I max minus I minimum by 8. 2 root 2 whole square means 4 2s are 8, like that. The power of output can be expressed in terms of RL, Vc, Ic, Vm into Im by 2, Im square into RL by 2. The maximum value of the power efficiency of class A amplifier is the simply estimation of efficiency. Because of these errors will be there, the expression is approximate. The assumption is that static output characteristics of the transistor are equally spaced in the region of the load line, increased in microamps. It will be increased by milliamps, and inputs we can take load line exactly, we can take the middle of the load line. Vm equal to Im into Zm, V max minus V minimum by 2. Now efficiency is nothing but how to define efficiency in class A amplifier. It is the ratio of signal power delivered to the load by DC power supplied by the circuit into 100. PAC is nothing but Vm into Im by 2. PDC equal to Vy into I. Vm is the peak value here, and Vm the value is nothing but peak value means Vm by root 2. We have to take Im is Im by root 2. VRMS is equal to Im by Vm by root 2. And IRM is equal to Im root 2. Suppose you substitute PS is Vm into Im. The Vm is nothing but half into Vm Im, and Vy by Iy into 100. Now the efficiency means here 1 into 100 means 50. Vm into Im by Vy by Iy. Here Vm is the peak value, and Vm equal to V max minus V minimum by 2. VRM is equal to Vm by root 2. Vm into Im, V max minus V minimum by 2. Im equal to Iy. Im equal to I max minus I minimum by 2, I minimum equal to 0. Let us substitute those values in the equation. You can get it as 25 V max minus V minimum by V by Vm into Im by 2 and Vy by Iy into 100%. P naught equal to PCC minus VC by 2 into IC. VCC minus VC equal to RL. This is for current component. P naught equal to VCC minus VC whole square by 2 RL. Here PDC equal to VCC into IC, VCC equal to VCC minus VCE by RL. Now efficiency is nothing but already we discussed how it is a ratio of output by input. Let us take 50 into 1 minus VCE by VCC, Vy equal to Vmax minus V minimum by 2. Now let us finally efficiency is equal to 50 into Vmax minus V minimum by Vmax plus V minimum. Now efficiency of the class A power amplifier series in we discussed 25 into Vmax minus V minimum by Vmax. Coming to transformer coupled, what is meant by coupled means the output stage of one transistor output is given to second stage of input is called coupling amplifier. Because here why we need transformer, we are using transformer here because in previous class amplifier we need to take class transistor only. Transistor of the collector output is given fed back to the input of the next stage of transistor is nothing but that is single stage transistor amplifier. We are take here transformer we have to take. Transformer purpose is AC amplifier circuit. It is the input AL signal should be coupled to the amplifier and output of the amplifier should be coupled to the load resistance. The coupling device should be such that it allows the only AC signal to amplifier circuit and blocks the DC component present signal generator. Because of we are interested amplifying the AC signal, the instead of capacitor transformer also we can take it as coupling here. Now here RS is the series resistance, VS is the series voltage, and we have to take a transformer at the initial. Here R1 and R2 and RE providing biasing and stabilization. RE means RE across this is CE is nothing but coupling capacitor, RL is the load resistor. The load resistor is connected directly to the output of the circuit, hence the quiescent current passes through the resistors resulting considerable waste of the power as it is does not configure to AC signal. The output therefore decreasing of an amplifier. Further, it is not advisable to pass DC component of the current through the output device to complete. The voice loudspeaker, this problem can be solved by using suitable transformer. Now here N1, N2 is the primary, N1 is the primary coil, N2 is the secondary coil, V2 is the secondary voltage, and N1 N2 ratio is into V2, we can take it as I2, and V1 by V2 is nothing but N1 by N2 whole square. The resistance of primary winding is given by RL is equal to V1 by I1, and resistance of the secondary is given by RL is equal to V2 by I2. Then finally RL equation is nothing load equation, N1 by N2 whole square into RL. Here's the single stage class A amplifier ICQ equal to VCC minus VBE by RB. VCE equal to VCC minus RC into RL. The merits of transformer coupling is most efficiency. Here we need to produce, that is 50%, and low power losses, then direct coupling. Loudspeaker is placed secondary winding, and large power is transferred towards the load at secondary side. Transformer use act as a matching transformer. And coming to push, this is about transformer coupling amplifier. And crossover distortion may be avoided by applying the slight forward bias to the base emitter junction, and both the transistor of the amplifier circuit is practically we reduce this distortion when the push-pull stages are used here. This is about transformer coupling amplifier. I will ask question. So what is meant by class A power amplifier angle representation? It is 180 or 360 or 90 or 270. It is a 360 degrees. Why means it is completely present waveform 360 degrees. Next class B